and welcome to another episode of Math Made Easy by Mrs. Roberts. So, I'm going to try to do something a little bit differently. I'm going to make a little mini series, and so this is going to be episode 1 of the Trig Integrals series. So, in this episode, we are going to go over just basic trig identities and do a little bit of review. So, the first thing that you see popped up on the screen here are the products and squares of sine and cosine. And these are really good to know, to have kind of at the back of your mind that these exist. And so when you multiply sine and cosine together, you get 1/2 sine 2x. So that's really good to know. The next one, and this is actually derived from a half angle identity, is that cosine squared of x equals 1/2 plus 1/2 cosine of 2x. And that can actually be rewritten a little bit prettier, I think. So we can actually also say that this is the same thing as cosine squared of x equals, well, these have a common denominator, 1 plus cosine 2x over 2. That's a really ugly equal sign. Let's fix that. Ah, okay. So, that is a really good one to kind of have just in the back of your mind, thinking, if I have a cosine squared of x, maybe replacing it with this half angle could be helpful. And same thing with that sine squared of x. Again, this is derived from the half angle formula. And this could be rewritten as sine squared of x equals 1 minus cosine of x over 2. So that's just a couple of your trig identities that you want to have in your back pocket. Here are the half angle identities written a little bit differently. So you want to remember that these exist as well. Here are the double angle identities. So if you have something like sine of 2a, you could replace that with 2 sine of a cosine of a, which when we're trying to take the integral of something like that, that could make our life easier because we could have a u and a du. Sine of 2a is not too hard to take the integral of. And then don't forget about these beautiful creatures. We love these identities. So these are our Pythagorean identities. And remember, the Pythagorean identities can be rewritten in a lot of different forms. So this Pythagorean identity, sine squared of x plus cosine squared of x equals 1, that is the same exact thing as cosine squared of x equals 1 minus sine squared of x. So if you have a cosine squared of x and you're like, I really want this in terms of sine, you could replace cosine squared of x with 1 minus sine squared of x, and then everything is in terms of sine, which could be very helpful. The other one, of course, if you wanted this to be sine squared of x, that's the same thing as 1 minus cosine squared of x. Which again, if you're trying to get things in terms of either sine or cosine, having those identities in your back pocket could make your life a little bit easier. And then, of course, you can rearrange these as well. Tangent squared of x is the same thing as secant squared of x minus 1. And cotangent squared of x is the same thing as cosecant squared of x minus 1. Now, the last thing that we want to keep in our back pocket as a reference are the derivatives of each of these trig functions. So the derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of tangent is secant squared. The derivative of cotangent is negative cosecant squared. The derivative of secant is secant tangent, and the derivative of cosecant is negative cosecant cotangent. One thing that helps me memorize these are the derivative of all of the c trig functions are negative. Cosine is negative, cotangent is negative, and cosecant is negative. Tangent and cotangent, their derivatives are squared. And I remember that just because cotangent and tangent are a little bit weird. So there is a little bit of memorizing here, but yeah. So what I would like you guys to do is I would like you just to refresh your memory on what all of these derivatives are and take a quick peek at your trig identities. That is going to make the next few episodes a little bit less overwhelming.